In this video, we're going to look at an example of calculating arc length. And if you haven't seen a proof of this formula for arc length, you should go check it out. It's pretty cool. All right, so here's our example. We're going to find the length of the arc from x equals 1 to x equals 2 of f of x equals x to the third over 3 plus 1 over 4 to the x. And just to get a little picture, this graph is shown over here. So we are finding the length between x equals 1 and x equals 2, which is going to be from here to here. We're going to find this length. All right, and that would be measured in whatever units, where this distance right here is 1 unit. All right, so if I were to take this distance and then like wrap it around this function, how many of those would fit? So we could probably approximate it. I mean, kind of looks like between around 2 and 3, just looking at it, approximating it. Okay, which is always a good thing to do. So here we go. Let's jump into this formula. We're going to piece this formula together. So our bounds, our a and b bounds, are going to be 1 and 2. We need to find this derivative and we need to square it. So what I like to do is just do that, find the derivative and square the derivative before I even set up my integral or worry about that. So actually, let me rewrite just f of x first as a power rule kind of a thing. Plus 1/4 x to the negative 1. So we're just going to use the power rule. So we'll drop the 3 down, multiplied by the 1/3 will just give me 1, and then reduce the power to 2. Drop the negative 1 down, multiply by the 4th, and that will drop the power to negative 2. Now the next thing the formula tells me to do is I have to square my derivative, so I'm going to do that. Now remember, when you see this squared without the brackets, you're squaring the whole derivative. A lot of times you'll see the brackets like up here, but it's a lot of bracket writing. You can skip that if you want. Just make sure you understand what it means. Okay, so if we're going to square this thing, it's a binomial, so we have to write it out twice and FOIL it or distribute it, however you like to think about it. All right, here we go. Maybe pause the video and multiply this out and then restart it when you're done. Okay, so we should get x to the 4th. Now, when I multiply x squared times 1/4 x to the negative 2, and I add those exponents together, I get x to the 0, which is just 1. So I end up with just negative 4th, which is kind of nice. Same thing's going to happen here. Another negative 4th, and then we end up with plus 1/16 x to the negative 4th. So a 4th and a 4th is a half, so we should end up with this. So far, so good. Okay, well, we know what's going to go underneath the radical here is going to be 1 plus f prime of x squared. So if I add 1 to both sides of this thing, I'm going to get x to the 4th plus a half plus 1/16 x to the negative 4th. Okay, so I think we're ready to set up our integral now. So our length is going to be the integral from 1 to 2 of the square root of x to the 4th plus 1/2. Don't panic. I know this looks pretty ugly, but I'll show you what we're going to do. Plus all that stuff. Okay, so let's talk about how we're going to handle that. So when you're dealing with these kind of problems and you've got a square root, what you're really looking for, if this is going to be integrable at all, you could have a u sub situation, which is not this because we don't have anything outside the integral, which is going to happen a lot of times with this arc length here because there's nothing outside the integral. So it's not going to be really nice for a u sub, you know, because you'd have to have whatever your u is under the integral, you'd take the derivative of that, and you'd probably need some kind of variable outside your derivative or integral, square root, and you don't have it. So what we're really hoping is we can do something like this, okay? if we can take what's inside that integral and change it into something squared, that's going to be what we're hoping for. So if you feel like you can, you want to mess with that a little bit, pause the video and see if you can think about how you would write this as something squared. All right. If we're going to write this as something squared, it's going to look like that. And we want, you know, what's in the first parentheses to be the same as what's in the second parentheses. Now we've got a trinomial up here, so it's going to be a foiling thing. Okay, so just check it out. Whatever goes here and here is going to have to multiply to be that. Right? So what's it got to be? X squared. Good. Okay. Now we'll see if this is going to work out. We'll see. All right, let's take all that pink highlighting away, and let's put the pink highlighting here. Now what goes here and here is going to have to multiply to be that. All right, that's a perfect square as well. That's 1/4 x to the negative 2. And it would be positive, right? Positive, and 1/4 x to the negative 2. But does it give me my middle term? Well, let's test it out. I know it's going to work for the first and the last term. So let's check the middle term. If I FOILed this out and I multiplied those two things together, well, the exponents would add to be 0, so I would just end up with a 4th. And if I multiplied those two things together, I'd get 1/4 x to the 0, which is a 4th. And if I add those together, oh my goodness, I get a half, which is what I have here in my middle term. So these two binomials do multiply together to give us this trinomial. That's pretty crazy. But that's what you want to look for when you're doing these length problems. Otherwise, you're probably just going to have to use technology to evaluate the integral. So always see if you can factor it into some kind of a square. Now, great, we can take the square root of it and all that, but remember, the answer to the square root of x squared is actually the absolute value of x, because if x is negative, it's going to be a positive after you square it. So we really want to make sure that what's under here is positive. So let's just think about how we got that, what's underneath the radical. Let's go back. What do we have? We have the derivative of f of x between 0 and 1. Well, take a look at this function. What could you tell me about the derivative between 0 and 1? That function's increasing, between 1 and 2. My bad, between 1 and 2. This function is increasing between 1 and 2, so that derivative's positive. Great, that derivative's positive. Okay, now we're going to square it. Great, still positive. Now we're going to add 1 to it. Still positive. So in this particular example, all this stuff under here is positive. So we can do the square root of this stuff. Keep in mind, we still haven't even taken the integral yet of x squared plus 1/4 x to the negative 2 dx, right? So what we did there was we canceled out the square root with this squared, or they undid each other. Okay, great. Oh my gosh, we are finally ready to take the integral. Goodness sakes, let's do it. I'm going to go through this part kind of fast. Maybe you even want to pause the video and try it yourself and see if you get the right answer. All right, so we're going to use our power rule for integrals. Let's see, we're going to add 1 to negative 2, which is negative 1. So that's going to give me, and we're going to multiply that by the 4th, and then add 1, and we're going to evaluate that from 1 to 2. Okay, so plug in 2, we get 1/3 times 8 minus 1/4 times 1/2. And we plug in 1, and we get 1/3 times 1 minus 1/4 times 1. Now we're getting to the interesting stuff, right? Just kidding. Okay. Minus 1/3 plus 1/4. All right, let's see. What would I do? I would probably put these two guys together. So that would give me 7/3. And then 1/4 is 2/8 minus 1/8. is an eighth. This is the place where I make mistakes. How about you? All right, we get ourselves a common denominator, so we'll multiply by 8, multiply by 3. So we're going to have 56 plus 3, which is 59 over 24. Oh, we made it. 59 over 24. That's not approximately. Let's write this, because remember at the beginning we made a little estimate, which was kind of interesting based on the picture. So 24 goes into 59 twice for 48, which leaves me 11. So it's right around 2.5 units. After all that, do you remember where we came from? Remember how we estimated right here, this is 1 unit. So it kind of feels like, 1, 2.5, maybe something like that. That was our estimate. That's not exactly equal, but you get the idea. All right, so there's a lot of steps there, a lot of places to make little mistakes, so just be really careful. Look at each step before you go to the next one, and I hope that this example helped.